Hi, this is my Sports Science 6.3 presentation on the numerical mode. Kinetics is an area of mechanics that deals with the actions of force. A force is a pull or push upon an object that happens from an object's interaction with another object. It is the study of reaction rates and how they are affected. Many factors such as concentration, pressure, temperature, and enzyme activity can impact the rate of reaction. Kinetics are linked to linear kinetics, which include force, gravity, mass, and weight. Angular kinetics also goes with kinetics, and these include torque movements and levers. Kinematics is the branch of mechanics that deals with motion or movement. It describes the motion of points, objects, and systems of groups of objects without reference to the causes of motion, such as forces. The study of kinematics is often referred to as the geometry of motion. Objects are in motion all around us. The equation which goes with kinematics is mass times acceleration. Linear, curvilinear, and angular and general motion are linked with kinematics. Now on to areas. Linear motion is a one-dimensional motion along a straight line and can therefore be described as using only one spatial dimension. The three major types of simple linear motion are constant velocity motion, uniformly accelerated linear motion, and freefall. The basic physics quantities used to describe the motion of an object are position, distance, displacement, speed, velocity, and acceleration. An example of linear motion in sport is a ball moving in a straight line, or when an athlete, such as a downhill skier, holds a particular body position as they move in a straight line. A sprinter shows linear motion when they run in the same direction for their run. The more linear their motion is, the better their performance will be. Angular motion is defined as the motion of a body about a fixed point or fixed axis. It is equal to the angle passed over at the point or axis by a line drawn to the body. Angular motion can be seen in sporting activities. Whilst doing jumping jacks, both the arms and legs rotate around the anterior axes, which pass through the shoulder and hip joints, forming a point of focus for where the motion passes through this activity. A projectile is an object upon which the only force it has on it is gravity. The gravity acts to influence the vertical motion of the projectile, which therefore causes vertical acceleration. The horizontal motion of the projectile is the result of the tendency of any object in the motion to remain in a motion of constant velocity. In sport, projectiles include objects and athletes in flight as a result of throwing, batting, kicking, and jumping. General motion is linear and angular motion together. Numerical model creation. Models used to assess a sporting performance require three elements of research from available literature, an elite level athlete, and a specific athlete. All of the research is then combined to perform an overall analysis. Literature review. This is called secondary research as it uses data and information that already exists. This may involve reading articles in books, scientific or educational journals, and the internet. You could see the experts in their fields, what they've said, and who already have conducted research or can provide information to help with a particular study. Elite level athlete. Part of a model may come from the analysis of an existing elite athlete in the sport being studied. For example, in basketball, it could be one of the greatest, such as Michael Jordan, to analyse the way he slam dunks. Or in tennis, it could be Serena Williams to analyse her serve, and in golf, it could be Michelle Wire to analyse how she puts. By selecting an elite level athlete, you'd be looking to find highly successful examples of what you're investigating. Specific athlete. Use a specific athlete that has had an aspect of performance previously analysed. This would enable the researcher or coach to assess the success of previous analysis and a change to technique or training program, or it could be used to investigate areas of improvement had the athlete been more successful in the past. For example, a tennis player who had a high percentage of first serves and has now dropped the percentage. Analysis of the serve would highlight what improvements are required to be successful again. When talking about evaluation of numerical mode, an overall evaluation of the numerical mode requires pulling together all of the data and sources of information and summing up the conclusions and next steps. This involves analysing and presenting qualitative data in graphs and charts, analysing images and video footage, and using existing secondary to add value to research findings. Now on to linear motion. Scalars are single and one-dimensional quantities. A scalar has a unit and a value attached to it. For example, it could be something like time being measured in seconds and the amount of time involved in completing an activity. A good example of this would be an athlete involved in timed events such as 100-meter sprint or a longer duration race such as a 5K. Another example might be distance. The unit being measured might be meters, and the value could be the number of meters travelled. A good example of this might be an athlete competing in long jump, high jump, or javelin. Vector quantities must have some form of direction in them. An example would be a sprinter running a race of 100 meters and the speed of the athlete being measured in meters per second, which is the scalar. Speed and velocity are used to describe how fast something is moving. For example, how fast an Olympic rowing crew travels over a 2-kilometer course from start to finish. Speed is the rate of change of distance and is a scalar quantity, such as kilometers per hour or miles per hour. The formula to calculate speed is speed equals distance divided by time. Velocity is the speed of a body in a specific direction and is the rate of change of displacement. Unlike speed, velocity is a vector quantity, which means it has a direction as well as a magnitude. So, if the direction of the moving body changes, then the velocity changes, even though the speed might stay the same. This might be applied to the path of a rugby or football player who covers a certain distance, but will need to change direction to avoid being tackled or intercepted by an opposing player. The formula is velocity equals displacement divided by time. Now for distance and displacement. Displacement is how far a body has moved from its starting point. It is the shortest distance between the starting point and the finishing point, and it could be referred to as how the crow flies, which is a saying that for the most direct route between 2 points. For example, a windsurfer in a race will have to trace backwards and forwards in a zigzag shape to cover a distance of 200 meters. Therefore, the windsurfer is likely to cover a much greater distance than the direct route between 2 points. Distance and displacement are both measured using the scalar quantity in meters. Acceleration is the rate at which a body changes its velocity. It also is an example of a vector because it has scalar unit such as meters and also some form of direction. An example of acceleration is best seen through something like a sprinting race such as 100 meters. An athlete such as Usain Bolt will have a rapidly increasing velocity over the first 30 meters of a sprint to reach the maximum speed and velocity. This initial increase in velocity is called positive acceleration. Once the race is finished and Usain Bolt begins to decelerate and slow down, he then goes into a phase called negative acceleration. The formula for acceleration is ms minus 2 equals vf minus vi divided by time, or velocity final minus velocity initial divided by time. Graphs are a good way, an effective way of showing movement visually. The two main types of graphs that are most useful for our particular study of basketball are distance time graphs and speed time graphs. Graphs are particularly good at capturing data and show it in a way that can be easily understood and analysed. Some examples of different types of graphs are shown on the screen. Distance time graphs. The x-axis on this type of graph is always time and the y-axis is always distance. The two graphs on the screen are time distance graphs for acceleration. The acceleration one shows that the distance covered over time is increasing and therefore the athlete is getting faster. It shows a steep curve upwards. The deceleration one shows that after the initial acceleration, which covers distance quickly, it begins to flatten out and distance covered slows down. The line would eventually dip down as the distance covered comes to an end. Velocity time graphs. These graphs show how fast a person or object was travelling at a given point in time. The x-axis is always time and the y-axis is velocity. A graph such as this might be useful for analysing an athlete's velocity at certain points during a race. The analysis could be used to design a specific training program to improve the athlete's performance in certain parts of the race. This graph shows, the accelerating one shows that the athlete's acceleration and fast velocity at the start of the race. The steep incline indicates a rapid velocity at the start of the race, such as a 100-meter sprint. It would eventually reach a peak and then flatten out as the athlete reaches maximum velocity. In the one to the right, the sprinter might be nearing the end of a race. They will have reached peak velocity at the end of the race and they are slowing down and the velocity decelerates. The graph begins to flatten out and shows a drop in and decrease in velocity.